Hello, Physics PT11 A part. Question number 1. A ball of mass 100 gram bounces on a hard surface. Every time it hits the floor, it loses a quarter of its kinetic energy. If the ball is released from a height of 1 meter, after how many bounces will the ball bounce no higher than 0.25 meter or 1 over 4 meter. So it is that is start from 1 meter, and this is a bounce and this is rebounds, and then it is 1/4 of is lost, which is a 3 by 4, and this one is bounce and rebounds, and this is again 1 by 4 lost. So 1 by 4 lost here, 1 by 4 lost here, 2 1 by 4, and that means 3 by 4 raised power 2, and this is 3 raised power 3 or 4 raised power 3. So this is 3 raised power 1, 3 raised power 2, 3 raised power 3, and so on. And so that we have to find that what is the bounce number when its height is 1 over 4 meter. So the first bounce is 3 by 4. Second bounce 3 by 4 raised power 2. And this 3 by 9 by 16. So it is still greater than, because uh, uh, 1 by 4, 1 by 4 multiplied by 4 and divided by 16, 4 16. 9 is greater than 4. So this one. Third one is 64 and 27. And this one is 1 by 4, 16. 16 multiplied by 4, 4. 4 is 64. And this is 16. 16 is less than 27. So next one is 81 by 256. And multiply by 4 up and 4 down. So this will be 256 and 64. 64 is less than 81. 81. And next one is uh, raised power 5. So this is a 243, and then if you multiply with this one is a 256. 256 is greater than now, so it's greater. So that is that the fifth bounce, the height will be less than a quarter of a meter. Next question. How the resistance of following components vary with the temperature: ideal wire, light bulb, filament, and a thermistor. Ideal wire is Ohm's law, so it is equal to, this is temperature. Not ideally, is the temperature vary linearly, and light bulb filament, it varies like this one is exponential, and then thermistor is also, this one is exponential decay. Next question, question number 3. A moon of Jupiter, Io, or Europa, travel around the Jupiter in a circular orbit. The radius of the Europa is 1.6 meter, 1.6 times the orbit of Io. In what ratio that the moon orbit periods? So that we have to find the time period of the orbits when there's a ratio of their orbit. So Io and Europa, O is this one, and IE is Europa. IE over IO is 1.6. Then time period, we have to find the ratio of the time period. Kepler law, time period square is proportional to the radius cube. So TE, Europa over IO whole square is proportional to the radius of E and a radius of the radius R of the IO whole cube, which is, this radius is equal to 1 by 6 raised power 3. then the ratio of the time period is equal to 3 by 2, which is nearly equal to double. So the time period will be double. Next question is a rover want to cross a river to a point on the opposite side of the river bank directly opposite where she will start. The distance to cover is 100 meter. She want to cover in the river in 10 second. So that means its speed is 10 meter per second. The river flows uniformly 7.5 mile meter per second. How fast are boat and what angle relative to the flowing water? So this is a river which has a speed of 7.5 meter, and this is 7.5 meter, and this is the speed. This is the speed of the. This is the length of which was 10 meter, and she want to cover into 10 meter in 10 second. This is a 10 meter per second, and that is actual speed. So this is a 7.5 and this is a 10. So the angle is the ratio of opposite to the base. So 7.5 by 10, which is equal to 3 by 4. This is arctan 3 by 4, which is a pi by 2. And the actual angle is this one. So with respect to the river, and the river is equal to pi. This is the 90 degree, and this will be 90 minus arctan 3 by 4. The speed if will be this square and this square. This is equal to 10 square plus 7.5 square, which is a 12.5 meter per second.